Hello everyone, I am Samuele and this is Neutrino, the zero particle. Neutrinos win the minimalist contest. Zero charge, zero radius and very possibly zero mass. This is how Leon M. Lederman described neutrinos in one of his books, but let's see something more. Probably you already heard the word neutrino when, in September 2011, Opera researchers announced that their measure of neutrino's speed was higher than the speed of light. Unfortunately, the results were distorted by an error on the experimental device, but a question remained in my mind. What is a neutrino, and which are the applications of its study? First of all, a neutrino is a neutral lepton. It means that it has no electrical charge, and it has a half-integer spin. It seems to have mass, but it is so tiny that it is very difficult to measure it compared with other known particles' masses. A peculiar characteristic of this particle is that pass through normal matter without any interaction, because they are not affected by strong force, gravity, and electromagnetic force. Furthermore, there are three types or flavors of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. Each one is a product of the interaction of his corresponding particle. Recent experiments confirm neutrino's oscillation, through which a neutrino can be measured with a flavor different from the flavor of his creation. How do they form? Neutrinos are a product of weak force interaction, like in the beta decay process, where a neutron decays in a proton, an electron, and an antineutrino. That is an antiparticle because the algebraic sum of particles and antiparticles before and after the reaction must be constant. The inverse process of decay can be used to detect them. If an antineutrino and a proton collide, they form a neutron and a positron. We can reveal this interaction, for example, using a hydrogen chamber, because the neutron will hit another hydrogen nucleo, it means a proton, to form deuterium and emit a photon. And then the positron will annihilate himself with an electron. So they will emit two identical photons in opposite direction. Due to the revelation of these photons, we measure the presence of a neutrino. But how can we use it? There are a lot of things we can do by detecting it. Because of neutrino's unique features, it can be used to make a tomography of the Earth, to identify the presence of radioactive minerals. It could also be an important instrument to investigate the inner structure of the Sun, that is a big source of electronic neutrinos as a product of nuclear fusion. Neutrinos can be even used to study far celestial objects as supernovae or black holes, or, watching farther and farther, the youngest universe, as it was some moments after the Big Bang.
The study of neutrinos is a field with a great potential that can radically change our view of the universe.